system, right?
Okay.
So you've recorded in the cloud, right?
Yes, ma'am.
Okay, done. So let's suppose you got the final output of flood, and you also classified into five classes from 1 to 5, where 5 is representing very high, 4 is representing high, then medium, then low, then very low. Those are the five classes you have in your raster data. Then you have to use what tool? You have to use the tool you can use the tool like raster to vector converter, so that you will have now five area of interest geometry with you.
And the last data which I created, like
Mhm. The intersection one.
this one,
Mhm.
results near school, I have to convert it this.
Yes, the raster data that you created after getting the flood analysis, the weighted overlay output that you got at the end.
Ma'am, we didn't do that actually. We for this the steps were different, like buffer and intersection and all that. We didn't do HP for this.
Okay, okay, you didn't do the AHP. You just perform normal intersection and all those things
Yes,
to get to
ma'am.
the
Because
analysis.
for this, when the PDF was shared, there was no HP in that. It's
Okay,
just
okay, sure. No problem. So in that only, then you don't need to do the raster to vector calculation then you can simply visualize. I'll just show you what kind of visualization then I'm saying in terms of categories. Uh, I had this CSV data of school zones, for example, and then I had a separate file for districts. Then what we did is, okay, fine. Then you'll get confused. I was in the misconception that we were doing the HP thing. Just share your data only. I will check that. Okay, so how have you got this risk zones near schools?
ma'am, through buffer
You have
this
created the buffer around the river boundaries, and
yes,
then mm, with that buffer, then what we did?
school buffer we did, then
Uh,
river buffer
yes.
and intersection.
Okay, 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 fine.
I'll just open the steps once.
Why have you actually used the clip river dim?
It was a process in that. Uh,
Can you show that steps?
yes, yes, ma'am. I'm searching for that. Just a second. Ma'am, I've shared you on the WhatsApp.
Okay. Okay. We have
People,
acquired the data. We had the DEM, then we have the school layer, then we imported layer buffer around uh, river. And then dissolve to the buffer. Okay, fine. We have the river buffer. Then we have elevation layer. After the elevation layer, so after the elevation layer, you had the raster extractant, clip raster by mask layer input, risk dem by the river buffer. Okay, fine. Then identify zones near schools, buffer schools, vector geometry, buffer, vector law, intersection, school buffer, overlay, clipped risk. Okay, so we had done that step of raster reclassification. There we have the categories of 1 to 5. Okay, like
Mm.
5 is representing high risk zone. And
Mm.
then have we done that river buffer
Yes,
clipping
ma'am.
through the
Yes.
risk dem?
Mm.
Where is that output? This is risk zones.
Yes, ma'am. This one.
Can you
This
switch off
dam.
that?
This risk dam, I guess. This is the one reclassifying them.
Okay. Can you switch off that green one? Risk zone near school. Switch off that. Switch off risk zones also. Okay. Risk dem. This is risk dem. Okay. Wait. So, can you open the table for risk dem? Okay. So here, see, here we have categories. So now go to the symbology for this risk dem. So this is also one of the output that you have. Change the single symbol from here to the category and then classify. It will classify into 5 categories. Okay, there are none. Okay, choose the field from the values. Choose the DN. Okay, now classify. Delete first and then classify. Delete all. Huh. Now classify. Okay, so now we have 5 classes and there is other, uncheck the other option. Okay. And then apply and save. Okay. Okay, so instead of that, we'll put some graduated colors so that we get an idea. We'll put some, right click on that, go to the symbology. From the color ramp, choose the color ramp from the random colors. Instead of that, choose just some greens or blues so that we have a graduated option here. Okay, so 5 is the blue. Okay, just a minute. So higher the class means higher the risk. So choose the blues from there. Blues option. So dark blue will be 5. Okay, now it's better. Save okay. So this is how it is representing basically that which area have high risk and you have classified that dem. Now from using this risk dem, what we will do, one thing, see there are multiple steps that you can do that either you just extract the values which are high risk and very low risk, only those two category from this, and then using that geometry polygon just clip the the buffer that we created, river buffer. Which is the layer for the river buffer?
This one.
Okay, switch on that layer, river buffer. Okay, this hole is the river buffer. Have you already clipped it using the DEM? I
Yes.
guess so. I guess so. That we have already clipped it using the river buffer. Okay, fine. Fine, wait. Okay, so in the intersection output, where have you got this risk zone? The brown one layer. Do you remember? Can you open the attribute table? Let's see what's there.
Mm, Discussion.
Okay. Can you scroll? Let's check if there are any DN number values in this. Not this scroll. Scroll on the right and left. Check if you have DN categories. Okay, now we have DN categories. So this is the one that we will use to showcase that which schools are lying in which categories. So open the symbology for this table. So see, one visualization, you have this one. This you can put in the proper layouting and everything. And what you can
This
show,
is done.
just this DEM, yes, risk DEM. So
Okay.
from this also, what you can show to the user, like end user, that okay, we have delineated this from the risk buffer and the river buffer, and then we have reclassified the DEM, and these are the areas where dark color is showing that these are the areas which have higher risk and lower risk, and these kind of category class you have classified. So this is kind of the story built up you have. So first you will display your risk DEM output. And after displaying your risk DEM output, then you will display your risk zones. So now we'll do the symbology for risk zones. Open this,
Categorized.
categorized, yeah. And then choose the DN column value, column. Hmm. And classify, uncheck this all other. Yeah, okay. And choose some graduated colors so that we have a. Hmm. Hmm. Yeah, you can choose this reds also. Huh? Okay. Apply on. Okay, that's it. Okay. Hmm. So, this. Wait. Uh, how have we got this output, the risk zone? Because the geometry is different for this. See, that is why I always say that organization is very important. You need to know that which layer is coming from which output. Otherwise, it's very hard to build a storyline because this we don't know. Do you remember where we got this output?
Ma'am, I guess it is the last step which we follow, like fifth one. Identify zones near schools, buffer school,
No,
and
but
intersection.
I can't see any layer from where you have clipped all these because this is still the output that we are getting from the river buffers. This is not. Can you check? Select this. Open this school buffer Miami on the map. On the map
Attribute.
only. Yeah, on the map only. Let's see first how it looks. Okay. Okay. Um, can we close everything? Let's see if it is intersecting with that. Not this one. Close the other ones, other layers. Risk dem and risk zones. Close that. Okay. So I guess we got this risk zone output after intersecting the school layer with the risk dim layer. Can you switch on the risk dim?
Ma'am, the last step was intersection between school buffer and clipped risk.
This is the clipped risk only. Your risk dim is the clipped risk
Yes, yes, yes.
output. So uncheck this. Okay. So I guess this is the intersection from that only. Risk zones are the intersection from that only. Check, select the risk zones now. Okay. Switch all other things off. Switch off all other outputs. School buffer and risk dem also. Close this risk dem also. Okay. Now open that risk zones near school. What is that? That
Attribute.
is the buffer attribute.
Yes.
Okay, risk zone near schools. So create a copy of this layer. Close this and create a copy of this layer. Hmm. So first, let's suppose this is the final output you have, that risk zones around schools output you have. So on top of that, open that school point layer, school CRS, the very first layer that you have. No, at the bottom you have that layer. Very bottom, yes, this one. Hmm. Yeah. So see, there are a lot of points, but what you can do, you can clip all the extra outputs, clip this school CRS pointer data using this risk zone layer that you have, and then zoom in, and give some nice symbology to the school, and then you can have a map where you can display it like the schools lying in the risk zones. And then what you can do, then you can derive numbers. How will you derive the numbers? Basically, then you can have what do some statistical calculations. From where you will do the statistical calculation? By doing the joins and all those things, and by creating the charts. Now comes the picture of chart, that how many schools are lying in how many uh, which risk zone. So let's suppose you are creating one chart where in the x-axis you have dn values. By dn values I mean risk zone 1, 2, 3, 4, 5. And then in the y-axis, what you will display? You will display the number of schools lying in every risk zone. So you have this map output for this analysis. You will zoom in and then you will display with a nice symbology this in the background, risk zone in the background. In the symbology, you will be able to see this 1 to 5. You will rename it as very high, low, and all those things. And then schools will be displaying there. And then along with that map, you will have a chart output. In that chart output, in the x-axis, what you will show? You will show the classes of the risk zones, like high, very high, high, medium, low, and very low. And then in the y-axis, you will show the frequency, means number of schools lying in that area. Is this clear? Like,
Ma'am, this chart will I'll have to do in Excel.
yeah, you can use, you should use Python. We have already did lot of exercises on how to create chart using the layer. In this risk zone layer only, you have all the information, right? In this risk zone, you have the school information, and then you have the uh, classes information. You have two columns. Simply, you have to plot using the matplotlib, plot between the two columns. In one, in the bar chart, in the x-axis, you need to put the DN column, and in the y-axis, you need to put the any of the column like the object IDs or something like that. Then you can create more chart. Like I mentioned, if we have grade information, can you open the table for this?
For which
Just
one?
load this layer in the Google Colab, and then after loading that layer, just use matplotlib library after loading the layer, and then you can plot the bar charts. Now open this attribute table, risk zones.
For which one?
This one, risk zone
This
only.
one.
Yeah. Yes.
I need to copy the columns. Hello.
Uh, uh,
Ma'am, your voice is breaking. Hello. Hello.
yeah. Actually, I got disconnected. Yeah. So you don't have to copy this. You remember
Extra,
in
extra.
Py yeah. So you must have this data with you, right? Is it a temporary file still in the QGIS project only, or have you saved this?
I have saved this.
How have you saved this output?
In the in a folder.
In a folder as a shape file?
Ma'am, and not the attribute table, but the map
Layer,
layer.
but the map layer, right? So
Mm.
we have loaded layers in our Google Colab, correct? Like when we did all the analysis as a shape file or as a geo package or as a GeoJSON file, you can load the files, and then only we have done plotting there. Do you remember?
Yes, yes, ma'am.
Yes, huh. So similarly, like if you have a shapefile layer or you have a GeoJSON file or any kind of a GIS format file, you have to just open this file in Google Colab. Simply like we used.
The shape file only, not. I don't need this attribute table for that.
So the shapefile anyways contain your attribute table. Like you
Yes.
will open that file as a geodata frame in
o-
Colab in Python, correct?
Okay.
So once you open that file as a geodata frame, so you will get the table and everything. Then you will have two options. You can visualize there also. You can have more symbologies. You can create folium maps using there. You can then add bar charts, create more different kinds of chart. So I have showed you two maps output from this. One was a DEM layer and another this the risk zone layer. On top of that, you have to visualize the school layer with a nice symbology of schools. Okay. After clipping this, you don't have to show all this
These two layer will be shown separately, like risk zones along with the school.
along with the schools on top of that, not separately in a single template, in a
Not
single.
that one, ma'am. This risk zones along with school will be one, and the
Yes.
risk dam would be another.
Would be another, yes, correct.
Okay.
Yes. So, and the school layer right now you can see you don't have to display all the schools. You only have to display schools that are lying inside your risk zone boundary. Okay. Huh. So that then only you will be able to get a zoomed look of your school layers. And then, so you have two maps ready. Then you'll come back to the chart section. When you'll come back to the chart section, in chart section, one chart I have told you, DN number means the classes, high risk classes on the x-axis and the y-axis, you just have to show the frequency, number of schools lying in uh, every class. Then the second output, what you can show that every class wise, like you have a grade column as well in your layer, correct?
Okay.
Hmm.
In risk dam.
No, in not in the risk zones only. In the risk zone, you have all the information for your analysis.
Yes, yes.
Hmm. Open that table.
Risk zones.
Yeah. Hmm. So in this, you have one column like grade. This grades. Can you check how many categories are there for the grades? Is it only 9 to 12th? Earlier you had that at the start. Yeah, this one. After type, this column, grades, last columns in this. The page that you can see, yes, is this one. Can you see?
9 to 12 only.
Is it 9 to 12 or are there more categories?
9 to 12 only.
9 to 12 only, huh? So then you can skip it. Then you have only one chart option from this data, which is
School.
frequency class wise.
Okay.
Okay. That you can do using Python, and you have to do only using Python only. Okay.
Okay.
Don't use QGIS for that.
Okay.
And
And
try writing code by yourself. And but if you get stuck anytime, then I'll let you know. But first try writing by yourself.
okay.
Mm. Go through those sessions. If you miss anything, go through the sessions where we have done plotting using Matplotlib and using Folium. You can also have all those visualization also you can have there only in QGI. Sorry, in Python itself.
Okay.
Mm.
And how should I represent this project? Like in yours, I saw that it was a website. After clicking it, there were four projects, and then after clicking that, there were detail about each project.
Yeah, so
So,
I'll just brief you on that also. So that was actually a website, but what you can do, you just need to create a PDF for that. Okay, just create a PDF. You right now you are only working in a single project. Later on, we will add everything into a single page. Uh, just
Currently I have three projects that I did. Like the first, this is the first one, and two more are from my thesis.
Okay,
And
so in that case, we can put everything together. So I will check what are the free hosting websites where you can put your PDFs together. I'll check that, or using Git only, then we'll put. First, you just create three PDFs. So you can imagine these are all just three PDF files that I had. Okay, so create a PDF where you have things like that, like this is the PDF. You can have more slides. It's not like that you need to be limited to 10 slides only. That was my restriction for the college restriction that they had, but you can just build accordingly, like start with a brief about like flood, if you're talking about flood right now. So a brief about flood, then talk about your study area a little bit, a basic template with a boundary of the city. If you have, if you don't have, then you can skip it for now. Then once you have that, then mention your aims and objective. For example, your aim is to get the delineation, like to have an insight or the analysis of the schools lying in the risk zone. Then you can
yes,
just have defined 2 to 3 maximum objective, a brief objective. Do not be very specific about what you're gonna do. Then
okay.
you can skip these two maps for now. Then you can have your methodology. In methodology, you need to put your steps.
Flowchart.
Step every single steps that you have performed. Either you used Python, then or in the steps you can then you can have a section like tech used at the site. Let's suppose here in the bottom I had this section data set parameter groundwater well analysis, so terrain and like that. So what you can do, you can have section like tech used. So in tech used, you can write QGIS, Python using Google Colab for your analysis, like that. That one section you have. Then you can have a data set section here only. In that data set, you can mention like Miami River and then river boundary and then DEM data from a SARTIUM, like that, 2 3 points. Just mention the name of the data set, no more explanation in a single slide, or you can have 2 slides depending how you're curating your slide. Okay, once that part is done, then you can create if you can create beautiful maps. If you think that it looking good, you can put all those data set in a single map on top of one another, school on the top, dem layer with a nice visualization at the bottom. Then all those to give a map insight of how your data looks like, raw data. Then what you can do, then you can start building your analysis. Like first point you did dem reclassification, so you can have the, not like, don't mention the technical term like dem reclassification. Just mention like something like risk zones in the just a minute. I'll think of something good name. You can also think of a name, something which represents your output. Let's suppose the DEM reclassification of high risk and all those things, how we have generated using just the classifying of the DEM. So you can do the risk analysis, elevation risk analysis output like that, and then you can have your DEM reclassify map with a legend and everything. Then after that, then you can just directly put your risk zone of school output, a map, and then a chart on the side, and 2-3 line of explanation what that map and chart is representing. That's it. Then if you want to have a basic conclusion at the end about your analysis, then you can write, let's suppose, see, I have written 18 portable location for ground recharge wells, 12 location for providing green infrastructure. So in your case, so you can just write like these many schools are lying in the risk zones, 12 risk zones, or 12 schools are lying in high risk zone, 2 are lying in low risk zone. These are lying in the high risk zone because it is lying in the low lying areas, because the elevation was high, low, such kind of thing. 2-3 points maximum. If you want to write, you can write. That's it. Then, if you know a little bit about that study area, you can write like if the some limitations you felt along with while you're working, some assumption if you have made, then you can write that. Otherwise, skip that point. That's it. For now, just that's it for your analysis. Then the code you are gonna you have used for Python map or something. For that, what you can do, just create a .py file. That py file you have, then uh, try to see how you can put your file .py file into the Git. Create a project for your single .py file, post that script into the Git, and then put that link here in your conclusion in your slide itself. Like the steps used, utilize for performing these tasks are this, and this is the code that I have used. And then just put a link. Do not put code snippets or something like that, because if somebody wants to access your code, they will just open that link and then they'll go there in your Git repository, and then in that Git repository, you can be as detailed as you want to be for your analysis. Like these are the steps I performed, then I have used coding, then I have used QGIS. So such kind of whole script, everything that you want, you can put it there in detail
Okay.
if you want to. That's it. So you can create
In
a,
in
yeah,
code section, apart from putting the links, I'll just represent the result, like the table I
yeah,
created or
yeah,
the bar
yeah,
chart I
yeah.
created,
Yes, in the code only, like in
and
Google Colab.
explanation for that
Yeah,
to ensure that.
in Google Colab, you must have seen me that whenever I load the data, I do some EDA, like exploratory data analysis. I try to fetch the CRS, I try to fetch the
Mm.
data frame, I try to study how columns are looking, all those things. So you can write more number of line of codes, like whatever you think you want to do for knowing your data better.
Yes, yes.
Mm.
Okay.
So you can have as detailed script as you can there, and then just put. So first prepare all these things. So once you are ready with all those things, I'm also actually searching so that I can share with you all where you all can put your portfolio without paying any kind of a money or anything. Otherwise, anyways, Git is always free, but to put these PDFs and everything, we'll see what we can do. Otherwise, simply if I show you my LinkedIn, so in LinkedIn, anyways, you can put your projects, have attach your PDF. In PDF, we'll put all the Git links and everything together. In LinkedIn, we have a project section, right? So
Ma'am,
simply in a,
I'll create separate PDFs for each project. Like,
yes, yeah,
how
separate
much
PDF for each. Yes, correct.
okay.
Do not merge everything together, because like every PDF
That
will
would
be
be
a,
very long actually.
yeah, yeah,
If
that would be very long. And like if somebody is not interested in that project, so every project is like showcasing your different skill set. Correct.
mm,
So it's better that you have a separate links, GitHub links, code links, and separate PDFs for all your projects. Okay.
okay,
Hmm.
okay. And ma'am, for the last track, like the track three,
Mhm.
from the last project, I was not getting like how to start that. Like, I'll show you.
Okay.
Mm, These are the projects. And these are the projects.
Hmm.
So if I choose any of these, like if I choose Urban Resilience Index using Spatial DB,
Correct.
or this is for like SQL. So
I will suggest that you should make some kind of a tool, some PyQGIS tool,
okay, ma'am,
rather
if I
than.
choose this climate adaptation priority zones, if
Hmm.
I so I'll have to what steps I have to follow? Like I've take a project from I have to choose any area from the like
Yes.
uh,
You have to choose any area, and first of all, you have to do some background, some research, like what people are doing in this space, what methodology they are adapting, how you can get to, let's suppose, like currently you perform this flood analysis. Okay, performing this flood analysis, there are like there are 10 ways to do that. Different people do it in different way. Climate adaptation priority zone is a very vague topic right now. It's still not very like uh, it's still not defined that what actually you have to do inside climate adapt. In climate adaptation, you can talk about air pollution, you can talk about like floods, you can talk about stormwater, you can talk about fire, wildlife. So it's very still in very like the doors are open to every kind of section. So you need to decide first that which particular area within climate adaptation I have to focus upon, and then you will go to the data. So first thing is choose any, I will suggest choose any five topics which you just can see from there and you think that I am little bit of interest in these topic. Okay. Then second step,
from climate itself.
eh, that's up
Like
to you. If you're interested in climate only, so choose a related topic using
okay,
climate, environment, and something like that.
and
And then
fight from this track, like I can choose urban infrastructure or climate or
anything. See, these topics are just shared with you all for somebody who cannot come up with their own topic. Okay, it's not like that you have to stick to these topics. This
oh,
is just to help you understand. Okay, topics are something like that. You're free to choose, curate your own topic, your own methodology, your own ways, your own insights. It's up to you completely. So that is why I'm saying that try to pick something which you think that you're a little bit interested. Choose any five from any of them and then do a little bit, spend a week, I will say. I'm not rushing you that finish everything fast. Spend a week on just doing, I feel that you are into research and everything. So you must know the importance of reading the research papers, right? So do some research on each topic, see what people are doing, what new you can add on. Because uh, my idea is always that if you're building a project, you should think like you can publish that as a paper. Okay.
so ma'am, in this every single topic is different. Like the first one, urban resilience is index is using special DB. That means from SQL we need to
Yeah,
perform.
so not just SQL. See, we have done the analysis in the classes that why we use special analysis is it was simply just to store the data. That
Mm.
was just a part of your whole project. That is not the whole thing. So why we use special DB? That while we were doing the analysis in Python, we were fetching the data either from
Table.
the local or from the drive, or you can access it from the DB. So in this, in the topic, the main topic is urban resilience index only. They have mentioned using special DB is just so that you utilize that skill of fetching the data from the PG admin. That's it. That is
We need to
just.
fetch the data from PG admin to GIS and then perform everything in again in
Yeah.
GIS.
Yes. So in our
Can
last
be done
session,
through PQ, PYQGIS also.
Yeah, you can do that. In PYQGIS also, I have told you, like in the last sessions, what we have learned. We have learned like how you fetch the data from the PG admin to the QGIS or to the Google Colab or to the Jupyter, and then you can perform the analysis in those data sets. That is what we learned.
Yes.
So if you want to do some analysis in your PG admin, like right now, let's suppose you are doing this flood, what you have done. Right now, what from where you are fetching this data? You're fetching this data from your local, you just loaded the layer in the QGIS. So the only thing that you have to change is that you have to load all this data into PG admin. And then from there you have to fetch in the QGIS and then you have to perform your analysis. Or if you want to do a little more advanced and analytical project, what you can do, you have to make a tool for you are doing the analysis of urban resilience index. You perform all those analysis, perform using QGIS or something like that. Then at the end of it, create a PyQGIS script, means create a tool for urban resilience index tool. So at the end, you will get three outputs in this analysis. One, a PPT where you are showcasing your story, that how what is urban resilience index, how do we calculate it, what is the methodology we follow, what are the steps that you need to perform, these are the output, this is my study area where I have tested this index, build this index. One output. Second output that you will be able to show using this is that I have built a data pipeline, that I have loaded all my data, not in my just my local. I have loaded all my GIS data into a spatial database. And then from my spatial database, I am fetching those data in my PyQGIS, and I have built a tool to automatically fetch the data from a DB and then perform the analysis and then give you the output. So
Okay.
kind of a whole pipeline you have built. So at the end, you are displaying or showing more skills to the somebody who is seeing your.
SQL is basically for storing, fetching, and then creating tables and.
Yes, correct. It is just for storing your spatial data. Yes.
Oh,
When you are working in a large organization or when you are working in a automated projects, automated pipelines or websites where frequently, so in that those cases you cannot store the data in your local systems. You have to store somewhere in your database. So that is just to showcase that you know how to use the database. Okay. And that tool you need to decide that either you want to go with PyQGIS scripting tool or you want to go with just Google Colab analysis. I would suggest to make a tool irrespective of how you are approaching your work. Make a tool at the end of it and display that this is the analysis I have done. I have used Google Python and all these things. I have used QGIS, and then I have made a tool as well, and it is shareable. It is open for everybody to use. They can use this tool, generalized tool, to have their own urban resilience index output like that. And
and
this applies to all the topics. Any of the topic that you feel use, you can create a tool for that.
okay, ma'am, the last time you showed us the flood analysis using PyQGIS and creating a tool for that. In the
Yes.
similar way, every topic would work, na? I
Yes,
have
in
to
some
take any study area and then take the data
correct,
and perform every analysis and then make a tool.
correct. Yes. The reason you can directly make a tool script as well, but the reason that we have split it into one seven section of script was that we were doing it for the very first time. And if you're learning and you're testing things, in those cases you have to uh, split your script into many parts so that it is easier to handle and understand. That was the reason that we created first seven script and then merged it into one tool. Okay.
Okay, ma'am.
Mm. Uh,
Every project would have different analysis, like some would have
yes,
ASP, some would have other process. I'll have
correct.
to search that, like which
Yes, you
topic.
have to search for the methodology. Yes. So first, before going into the methodology, try choosing 2 3 topics which you feel that you are interested in, and yeah, and then do some research what other people have done, where you think that there is a gap, what new you can offer. Like you are doing PhD, if I am not wrong,
Yes,
right?
ma'am.
Yes.
Yes.
So you know the importance of publishing the paper and everything. So you can either build a paper itself using these things only. This
Okay.
can be not just a portfolio project. This can be a whole research paper altogether. So it's up to you that how advanced you want to go just by doing small things. So
Okay.
do some research and find some research paper what other people have done, find some research gap like you do in PhD, find some kind of thing that okay, this is a thing that is missing that I can do, that I can build. Or let's suppose if I talk about urban resilience index, a lot of people have used different methodologies. Maybe you can think of something, okay, they are missing, this should be a part of index, and then we can include that thing and make it okay. But before, I guess, jumping into the new capstone, first I will suggest finish everything else, post your current projects, what you have done, you have completed. Mm,
Track one I'll post first, and then
ah,
after that I'll
yes,
start from track 2 and 3.
yes, correct. Huh. Track one first, complete everything, make a nice PPT, nice portfolio. Do not just write random text, make it a little beautiful portfolio, some like in a nice way so that it looks appealing, and then move to the track two and then move to the track two, any new thing. Okay.
Okay.
Yeah, okay. Okay then.
Okay.
Anything else?
No, nothing, ma'am. Thank you.
Okay. Bye bye.
Bye.
And try using Python as much as you can for your
Yes, ma'am.
analysis.
I'll use for the attribute table, creating bar charts and table for this.
Mm-hmm.
I'll do
And
that.
from next time, like for track three capstone, I will suggest completely use coding only. Do not do normal analysis using QGIS. Okay. Yeah.
And ma'am, one more thing.
Mhm.
Ma'am, is there any suggestion from your side for choosing a particular project, or which topics are more demand, or
What's your PhD thesis? मतलब topic like
yes,
your
ma'am,
domain?
disaster management is a flood only. Flood,
Okay, flood is your domain.
flood,
Okay,
LULC, and all that.
okay, okay. I'll think of something and then I'll let you know. Okay, I
Okay.
have this PDF also. I'll also go through it and then I'll see some if I find any research gap in this. Okay,
Okay.
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 Bye bye.
Bye.